So when we're using equations and specifically linear functions, we can use them to solve problems that involve a pattern and coming up with the next step or the next point that is there. So like I said, once an equation has been made for a linear function, any point on the line or in the pattern can be found. Each point is represented by an x value, which is the independent variable, and a y value, which is the dependent variable. Again, these form a coordinate point. The xy point. Okay. Now, when we draw out a graph like this, here we see a very small portion of the pattern. We see just from here to here. We don't see what's going on above or what's going on below, unless we were to make this graph much smaller and have the numbers to be much bigger. But if we have the equation for this line, we can use it to extend past these points that we have. So the first thing we're going to do is we're going to use the given graph here, and we're going to write an equation of the linear function. Two things that we need to know. We need to know our y-intercept, and we need to know our slope. Here's our y-intercept. Now on these types of questions, I will almost always give you the y-intercept as a nice point. You don't have to necessarily try to find it as a a decimal. It's going to be a nice point. Once we move on to some other things, then I'll give you other ones as well. Then we have to find another nice point, and I'm going to say that this is a nice point here. This is at 1, 3, and we're going to find what is the slope between these 2 points. Okay, so again, we can do that with any single 2 points that are on the line. Sometimes it's a little bit tougher to figure out what are our nice points, but in this case here, this one looks like a pretty good point, so we're going to use that. We could also use this point down here. This looks like it's a nice point right here. This is at -1, -7. In this case here, we have a run of 1, a rise of 5. So our b value is -2, and our m is 5 over 1. We have a rise of 5 over a run of 1. Therefore, our equation is going to be y is equal to 5x. We don't have to do the 1 underneath, minus 2. Okay, that represents this pattern here, and is going to represent any single point on the pattern. Well, let's use a secondary point that we had. This one right here is going to be our secondary point, and let's verify that this works for that as well. So we're going to say that we're going to use the point -1, -7. Let's plug those values in. -7 is equal to 5 times -1 minus 2. Well, 5 times -1 is -5, minus 2 is -7. It works out for that, so we're going to say that this one is in fact correct. It's verified, which is good. That's what we want. We want it to work out for any single other point. Now, what is the point where the x value equals 100? Well, when x equals 100, we have the point 100 and then something that we don't know. We want to figure out what is the y. So we put 100 in for x. We say y is equal to 5 times 100 minus 2. Well, in that case there, 5 times 100 is 500, minus 2 is 498. So this point would be 498, or the point 100, 498. That's going to be that value, okay, or that point. Okay, that's a point that's going to be along the line. Now again, that's way past our x value here, and it's way past our y. But if we go past that, this would be a point that would be on there. It's one of the many points. Now, what about if y is 100? So this is the point where we have blank 100 right there. So we put 100 in for y is equal to 5 times, we don't know what this is yet. That's going to be just our x. 5x minus 2. We add 2 to both sides. So this is 102 is equal to 5x. We divide both sides by 5. And we're going to get that x is equal to 102 divided by 5. 20.4. So we have this point, 20.4, 100. Okay. Sorry, and might have missed all that. Okay. But that's the way it looks there. So we add 2 to both sides, divide by 5, and we're going to get this point right here, 20.4 and 100. Again, decimals are totally fine. They completely work. But we have to use them properly. Okay, they have to be proper there. Okay. Verifying the equation using points that can be seen on the graph is helpful to confirm that the equation created is correct. Okay, we want to make sure it's correct, and we can do that by confirming with another point, or a different point that is along the line. Now let's look at a second example. In this case here, we don't actually have a graph, but we're given two values that are going to help us to solve this problem. So we're told that Trevor runs a taxi company which charges a flat fee of $3.50 plus $1.75 per kilometer driven. Well, if we look at this here, this is definitely our rate of change. Okay, how things are changing, and this is our starting point. We know our rate of change is M. We know our starting point is B. So B equals 3.5 and M equals 1.75. Now here's where we can do decimals for M, and that's just fine. You can keep it as a fraction as well if you really want to, but we're gonna do a decimal. So we plug them in. Y is equal to 1.75 X plus B, where X is equal to the number of kilometers driven, and Y is equal to the cost of the ride. Okay, domain and range of our equation, because we want to put that in as well. So our domain, X has to be greater than or equal to 0, because again, number of kilometers driven is going to start at 0 and go up, and range, Y is greater than or equal to 3.5, because we start at 3.5 and go up from there. So that's where we get our domain and range from. Now, what is the charge before Trevor has driven anywhere? This is where X equals 0. Okay, so we plug 0 in. Y is equal to 1.75. And sorry, I missed that here. I think I said it, but I forgot to put it in. This is 3.5. Times 0 plus 3.5. 1.75 times 0 plus 3.5 is 3.5. So the charge is $3.50. Okay, that's going to be the charge before he's driven anywhere. Now, how much does Trevor charge if he has driven 5.5 kilometers? So this is where X equals 5.5. So Y is equal to 1.75 times 5.5 plus 3.5. Now again, use your calculators for this. I'm glad to do that. 1.75 times 5.5 plus 3.5 is 13.125. He charges $13.13. We would round that up due to the fact that it is that's kind of where the rounding would be, and we do 2 decimal places in general, but it also is money, so we do 2 decimal places. Okay, and then finally, if one ride costs $7.53, how far has Trevor driven? Well, in this case, Y is $7.53. There's our total charge. And so we do 753 is equal to 1.75x plus 3.5. We subtract 3.5 from both sides. So this is 4.03 is equal to 1.75x. Divide by 1.75. These are going to cancel out right there. And we have 4.03 divided by 1.75. X equals 2.30 kilometers driven. Now again, if you are in my class and you are working on the assignments, you can finish off the assignment LI.04, numbers 4 to 11. I gave out the other ones earlier, and you can finish off those.